Section 3.3, page 2. So now let's talk a little bit about differentiation when it comes to logs. What may happen is we could have a pretty complicated function. For example, it's involving multiple derivative processes that we know. And what we can do is we can simplify the problem by essentially taking the natural log of both sides. This will force us to use implicit differentiation, but as you'll see, it's really just one quick, easy extra step. So don't forget our three major laws of logs. Imagine I'm asked to differentiate this problem. Hopefully you recognize this one's crazy. You're going to have a product rule because I've got two pieces in the numerator. You're going to need a quotient rule because I have a numerator and a denominator. And then part of that numerator and all of that denominator, they're chain rules within themselves. So instead, we're going to go ahead and take the natural log of both sides of this problem. Then we'll use the laws of logs to rewrite the problem. Then we'll be ready to take implicit differentiation. So I have the log of y on the left. I'm going to leave it that way. But since I was seeing the numerator as a product, I can see it as the log of the first term plus the log of the second term that was multiplied with. And because the single log was divided by this, we can subtract the log of that denominator term. Already it looks a lot nicer for a derivative, but don't forget, if we ever have exponents, we can bring those out front depending upon kind of how the problem's written. This 3/4 can go in front of my log. The 1/2 can go in front of my log. The 5 can go in front of my log. So now I have a problem where the derivative is much easier. Now here's where you have to be careful though. I'm taking the derivative of a natural log. The rule is to put the variable in the denominator, multiply by the ln of the base. But if the base or the function looks like ln already, then that's taken care of. And then we need to take the derivative of the denominator that we've created, the variable. Now, generally the derivative of y is 1. I mean, it is 1 here, but our question only had x's in it. So through implicit differentiation, we need to write dy dx, or I wrote y prime. When I go to take the derivative of an x variable, I'm just going to copy a coefficient. The derivative of the ln of x is 1 over x, and I don't need to put x prime because this would be like dx dx. It just simplifies to 1. Again, I'm going to put my 1/2 out front. I'm going to put my x squared plus 1 in the denominator, but it's more than x, so when I take the derivative, x squared becomes 2x, plus 1 becomes 0, and I do have a 2 in the numerator that'll cancel with a 2 in the denominator, so that I will just have this x over my denominator. Minus 5 for my coefficient. Take the variable and put it into the denominator and the derivative of the denominator, so I can multiply these to get my minus 15. So at this point, I've got my derivative and it looks pretty good, but here's the problem. Remember, we're trying to find just the derivative. I need y prime alone by itself on the left. So I want to get rid of this denominator of y. So if I multiply both sides by y, the y prime will be alone, right? The y's will cancel off on the left, and when I multiply on the right, it's still there. Feels like I'm done, but again, our question only had x's, and so our derivative should only have x's, not this y. So we get to focus on the fact that in the original question, y was equal to this big old giant quotient with a product in it. So where y is, I can just put that big old giant quotient where there's a product in it. Now, you'll notice there's a comment down here that example 3, which we just finished, we had the choice. We could have taken the derivative using a product rule, a quotient rule, and a chain rule, and it would have all worked. But I believe the way we did it seems a little bit more efficient by taking the natural log. It just seemed easier to me. We're now going to look at a problem where we do not have a choice to make that decision. Let's look at it and why. My variable is x to the power of the square root of x. My variable is in both the base and the exponent. So I have no choice but taking the ln of both sides, requiring me to use implicit differentiation. So I take the natural log of y, I take the natural log of x to the square root of x I wrote as x to the 1/2 power. That does allow me to use the law of logs to bring the x to the 1/2 power out front. I haven't done any calculus yet. All I've done is use a law of logs. Remember, I cannot move that 1/2 in front of the x because I don't have a log in front. So as I now look at this equation that I'm going to take a derivative of, don't forget we're going to need a product rule because we have an x times some other portion with an x. So if f is x to the 1/2, then I'm going to bring the 1/2 out front, subtract 1 to get a negative 1/2, which would go to the denominator. The natural log of x has a derivative of just 1 over x. So I'm ready to use implicit differentiation involving the product rule I've prepared for. Looking at the left side, the natural log of y is to put y in the denominator. I don't need an ln of the base in the denominator because I already have an ln in the question. When I take the derivative of y and just get 1, I need to account for the fact that this function was solely in terms of the x variable, so I need my dy dx, or y prime is another way of writing it. When I take the derivative of the right side, I start off with f prime, which we already found, times g, which was asked in the question, plus, because of the product rule, my g prime times my f. So let's go ahead and look at what's happening here. On the first part of the product rule, we're really just sticking the ln over the denominator. On the right side, it's going to simplify to a 1/2 in the denominator, right? I've got a whole x in the bottom. I've only got a 1/2 an x on the top, which will cancel, leaving me with only 1/2 an x in the denominator. And again, I wanted y prime alone. So I'm going to multiply both sides by y to cancel on the left, but then show up with that y on the right, where I'm going to substitute back with the original question, y equaled x squared root of x. So just to finish up this statement at the bottom, we had said we didn't have a choice about taking the log of both sides. And just to reiterate, it's because the variable was in the base and the exponent.